Imagine a planet bathed in the warm glow of a distant sun. A place where the light filters through an atmosphere unlike any we've ever seen, casting an otherworldly hue across the landscape. This distant sun, though far from our own, provides the energy needed to sustain a world teeming with life. Lush, alien forests stretch across continents, their strange flora swaying in the gentle breeze. These forests are home to plants that have evolved in ways we can scarcely imagine, with colors and shapes that defy earthly norms. The air is filled with the scent of alien blooms, a reminder that life finds a way to thrive even in the most unfamiliar environments. Crystal-clear rivers carve through the landscape, reflecting the twin moons hanging in the sky. These rivers are the lifeblood of the planet, nourishing the land and its inhabitants. The sight of two moons casting their reflections on the water is a nightly spectacle, a reminder of the celestial dance that governs this world. This is a super-Earth, a planet much larger and more massive than our own. Its sheer size and mass create a gravitational pull that is far stronger than what we experience on Earth. This immense gravity influences everything from the planet's atmosphere to the way life has evolved here. Its gravity is a constant, powerful force, shaping every aspect of life as we know it. The landscape itself bears the marks of this heavy gravity, with mountains that rise steeply and valleys that plunge deeply. Every step taken on this planet requires more effort. Every movement is a testament to the strength needed to overcome the gravitational pull. Could humans survive on such a world? The question is not just one of physical endurance, but of adaptation and resilience. Our bodies, designed for Earth's gravity, would face unprecedented challenges. Yet, the human spirit is one of exploration and discovery, always pushing the boundaries of what is possible. Let's embark on a journey to explore the challenges and wonders of life under the dominion of high gravity. This journey will take us to the very limits of human capability, testing our ingenuity and determination. We will encounter landscapes that defy our understanding, ecosystems that challenge our perceptions, and phenomena that stretch the limits of our scientific knowledge. As we venture onto this alien world, we must prepare for an experience unlike anything we've ever known. The moment we step onto the surface, we will feel the weight of this new world pressing down on us. Every breath we take will be a reminder of the differences between this planet and our own. The very air we breathe, the ground beneath our feet, and even the flow of time itself will feel different. The atmosphere, rich with unfamiliar gases, will challenge our lungs. The ground, with its unique texture and composition, will test our balance and strength. Time, influenced by the planet's gravity, may seem to move at a different pace, altering our perception of reality. Our bodies, evolved for the gentle embrace of Earth's gravity, will be put to the ultimate test. Muscles will strain, bones will bear more weight, and every movement will require more energy. Yet, through adaptation and perseverance, we may find ways to thrive in this new environment. But within these challenges lie incredible opportunities for discovery, adaptation, and a new understanding of the universe and our place within it. Each step we take on this super-Earth brings us closer to unraveling the mysteries of high-gravity worlds. We will learn not only about this alien planet, but also about the resilience and adaptability of life itself. This journey to a super-Earth is not just a voyage to a distant world, but a journey into the very essence of what it means to explore, adapt, and thrive in the cosmos. To comprehend the profound implications of living on a high-gravity planet, we must first grasp the fundamental nature of this powerful force. Gravity is the invisible hand that draws all objects with mass towards each other. The more massive an object, the stronger its gravitational pull. This means that on a super-Earth, several times more massive than our own planet, the force of gravity would be significantly greater. Think of it like this. On Earth, you might be able to easily lift a 50-pound weight. On a super-Earth with twice the gravity, that same weight would feel like a back-breaking 100 pounds. This difference in gravitational force has a cascading effect on every aspect of life, from the way organisms move to the very structure of their bodies. One of the most immediate and noticeable effects of high gravity is the increase in weight. If you were to step onto a super-Earth with twice Earth's gravity, you would instantly feel twice as heavy. This is because gravity is pulling you down with greater force, making you feel weighed down and sluggish. This weight gain wouldn't just be a number on a scale, it would have a significant impact on your entire body. Your muscles would have to work harder to support your increased weight, leading to faster fatigue and potential strain. Your bones, accustomed to the relatively lighter load on Earth, would be subjected to greater stress, potentially increasing the risk of fractures. Even simple tasks like walking or standing for long periods would become significantly more challenging. Imagine trying to walk with an invisible weight strapped to your back. That's what moving on a high-gravity planet would feel like. Every step would require significantly more effort, and you'd tire out much faster. This is because your muscles would have to work against the increased gravitational force pulling you down. Even simple movements like raising your arms or turning your head would become more difficult. Your balance would be affected, making you more prone to stumbles and falls. Over time, the constant struggle against gravity would likely lead to changes in the way we walk, run, and even stand. Section 5. Mighty muscles, sturdy bones, adapting to gravitational stress. While the increased gravity on a super-Earth would pose significant challenges to the human body, it's also possible that over time, our species could adapt to these harsh conditions. The human body is an incredible machine capable of remarkable feats of adaptation and resilience. When faced with the relentless pull of stronger gravity, our physiology would undergo profound changes to cope with the new environment. Our muscles, subjected to the constant strain of supporting our heavier frames, would likely become denser and stronger. This increased muscle density would be necessary to perform even the most basic tasks, such as walking or lifting objects. Imagine the strength required to move in an environment where every step feels like you're carrying an extra load. Over time, our muscles would adapt to this constant demand, becoming more efficient and powerful. Similarly, our bones under increased stress might become thicker and more robust to withstand the added weight. The skeletal system would need to evolve to support the enhanced muscle mass and the overall increased body weight. This could mean a significant increase in bone density and structural changes to ensure stability and prevent fractures. Our bones would essentially become the pillars that support our new, heavier bodies. This adaptation process wouldn't happen overnight. It would be a gradual transformation, taking place over many generations. Each successive generation would be slightly better adapted to the high-gravity environment, with small incremental changes accumulating over time. It would likely take generations for humans to evolve and adapt to the crushing gravity of a super-Earth. This slow but steady process of natural selection would favor those individuals who are better suited to the high-gravity conditions, ensuring that the traits necessary for survival are passed down through the generations. However, the human body is remarkably resilient and adaptable. Throughout our history, we have shown an incredible ability to survive and thrive in a wide range of environments, from the freezing Arctic to the scorching deserts. This adaptability gives us hope that, given enough time, we could also conquer the challenges posed by a high-gravity world. Given enough time and the right evolutionary pressures, it's conceivable that we could one day walk, run, and thrive on a planet with significantly stronger gravity than our own. Our bodies would be a testament to the power of evolution, showcasing the incredible ways in which life can adapt to even the most extreme conditions. The journey to such a future would be long and arduous, but the potential for human adaptation is boundless. Section 6. The heart of the matter: cardiovascular challenges in a high-gravity environment. The relentless pull of high gravity wouldn't just affect our muscles and bones, it would also place a significant strain on our cardiovascular system. The heart, responsible for pumping blood throughout the body, would have to work much harder to overcome the increased gravitational force pulling the blood downwards. This could lead to a higher risk of heart disease and other cardiovascular problems. Moreover, the circulatory system itself would face challenges. The increased gravity could make it more difficult for blood to circulate efficiently, particularly in the extremities. This could lead to swelling in the legs and feet and potentially increase the risk of blood clots. Section 7. Every breath you take. Respiratory adaptations for a denser atmosphere. Breathing, a process we often take for granted, would become a more labored affair on a high-gravity planet. The simple act of inhaling and exhaling, which we do thousands of times a day without a second thought, would require significantly more effort and energy. The denser atmosphere, held in place by the stronger gravitational pull, would create higher air pressure. This increased pressure would mean that each breath would have to work against a greater force, making the act of drawing air into our lungs more strenuous. This would make it more difficult for our lungs to expand and draw in air, requiring us to exert more effort with each breath. Our respiratory muscles, including the diaphragm and intercostal muscles, would have to work harder, potentially leading to quicker fatigue and a greater need for rest. Furthermore, the composition of the atmosphere itself would play a crucial role in our ability to breathe. The balance of gases that we rely on here on Earth might be very different on a high-gravity planet, affecting how efficiently our bodies can extract the oxygen we need. If the super-Earth's atmosphere had a different mix of gases than our own, it could pose additional challenges. For instance, an atmosphere rich in carbon dioxide or other gases that are not breathable for humans would require us to develop new technologies or adaptations to survive. For example, a lower concentration of oxygen would make it even harder to get the air we need. Our bodies are finely tuned to the specific mix of gases in Earth's atmosphere, and even small changes can have significant impacts on our health and ability to function. While a higher concentration of certain other gases could be toxic, gases like methane, ammonia, or sulfur compounds, which might be present in higher quantities on other planets, could be harmful or even deadly to humans. This would necessitate the use of protective gear or the development of new biological adaptations to filter or neutralize these toxins. In addition to these challenges, we would also need to consider the long-term effects of living in such an environment. Over time, our bodies might adapt to the new conditions, but this could take generations and involve significant changes to our physiology. Advanced technology, such as enhanced breathing apparatus or even genetic modifications, might be required to help us cope with the demands of a denser atmosphere. Ultimately, the ability to breathe in a denser atmosphere would depend on a combination of biological adaptation and technological innovation. As we continue to explore the possibilities of life on other planets, understanding and preparing for these respiratory challenges will be crucial for our survival and success in new worlds. Section 8. Fueling the machine energy demands and dietary needs. The human body is an incredible machine, but it requires fuel to function. On a high-gravity planet, our energy demands would skyrocket. Every movement, from taking a step to simply standing upright, would require our muscles to work harder, burning more calories in the process. This means that we would need to consume significantly more food to maintain our energy levels. Our diets might have to shift to include more calorie-dense foods, and we might need to eat more frequently throughout the day. The challenges of food production and resource allocation would be magnified in this high-gravity environment.